7.2, you should definitely have that sheet of paper with all of the the exponents with you. We're on page 407. All of them are there. They apply the exact same way when we deal with rational expressions, exponents. But if you have not have them memorized yet, keep the sheet next to you. Here's some examples of how we work with this. Put this right here. We have 5 to the half times 5 to the fourth. This is whenever we have the same base and we add exponents. This becomes 5 to 1/2 plus 1/4, or 5 to 3/4. I'm going to only do this once, but I do want to remind you, if you struggle with adding or subtracting fractions, please go ahead and go 1 divided by 2 plus 1 divided by 4. It's going to give you a decimal math fraction, and you can do that, right? We just have to add them. You can do this using a calculator to get your fraction out. Let's move to the next one. This is one of the properties that literally distributes the exponent. This becomes 8 to 1/2 and all to the second times 5 to 1/3 and all to the second. We know this. That gets timed out. This becomes 8. 1/2 times 2 is 1. I don't need to use it. Times 5 to 2/3. 1/3 times 2 is 2/3. Okay? If you need to do this, again, use a calculator, use the fractions situation, you'll get it back up. Example number 3. What if I have 2 to the 4th times 3 to the 4th and all of it to this power? There's 2 ways to do this. The book does it one way. I'm going to do it the other way, okay? I'm going to go ahead and distribute this. This becomes 2 to the 4th, all of it to negative 1/4, times 3 to the 4th, all of it to negative 1/4. They get timed, right? This becomes 2 to the negative 1 times 3 to the negative 1, or 1/2 times 1/3, or 1/6. If you look at the book, what they did is they wrote this as 2 times 3, all of it to the 4th power. 2 times 3 is 6. 6 to the negative 1 becomes 1/6. There's 2 ways to do it. I don't mind either way you do it. Number 4. 7 divided by 7 to 1/3. Remember we said if you don't have an exponent, put a 1 there, just to know. This is just a division. This becomes 7 to 1 minus 1/3. This is 7/2/3. And you leave it right there. You don't have to do anything to it. The last one is 12 to 1/3 over 4 to 1/3 and all of it to the second. There's 2 ways to do this, but to my opinion, it is easier to go this way, the way the book did it. They share the exponent. If you look at your properties, when it deals with this, a over b to the m equals a to the m over b to the m, okay? I can do this also backwards. I can start here and get here. I can rewrite this as 12/4, all of it to 1/3, right? Because this is distributed, and then all of it to the second power. Why did I do this? Because 12/4 gives me a good number. It's 3. To 2/3. Did I do this right? 1/3. Yeah, it's 2 to 2/3 to 2/3, and you're done. You cannot, if you put this in a calculator, you don't get a full number, a whole number. I mean, you're going to get a decimal. This is the final answer to it. Now, how would have you done it differently? This can be written as 12 of 2/3, because I distributed, over 4, 2/3, would be the exact same way. 12/4, all of it to 2/3, or 3 2/3. You could have just distributed, then put it together this way, then come to the exact same result. As we move on to example 2 and example 3. Example 2 is nice. You can use a calculator to play with that. And you'll know that when you can use it, because I tell you can use it, because the book will tell you not to use it. It's going to say do it without a calculator. I'm telling you, you can do it with a calculator. What if I have √3/4 times √3 of 16? If you remember the rules of square roots, of roots, as long as we have the same root, in this case we do, we can put them under the exact same root. This becomes 4 times 16. This becomes √3 of 64. If you put this in a calculator, you're going to end up with plus or minus 4. Oh, just 4. That's √3. It's an odd number, okay? 4 to the 3rd power is 64. You can use that by doing math. Option 4 of 64, you'll get 4. Let's try another one. Root 4 of 162 divided by root 4 of 2. Remember the rules of roots. As long as I have the same root, they can go under the same root. This becomes 162 divided by 2, or root 4 of 81. When you see root 4, please remember to think plus or minus. The book doesn't tell you this. I'm telling you this every single time. And when you put this in a calculator by doing 4, and then you go into math, plus 4, plus 81, and plus enter, you should get a 3. 3 to the 4th power is 81. And you get a positive or a negative 3 because that is an even exponent. Here's where the part that you're not going to like comes in. It's whenever we simplify roots that are not square roots or other type of roots. What if I say root 3 of 54? Well, do you remember this beautiful thing? That's an even number. It divides by 2, I get a 27. This divides by 3, I get a 9. This divides by 3, divides by 3. All of them are prime. This can be written as 2 times 3 times 3 times 3. And we talked in class that you're going to need to have as many as that root tells you in order to pull one out. So I need 3 of a kind to pull one out. Here they are. I have 3 3s here. I can pull one out. This is 3. Root 3 of 2. I only have 1 2. It cannot come out. So the way we do this is we do the little tree, and we see that we have 3 of a kind, or if that would have been a 4, we would need 4 of a kind, and so forth, in order to pull one out. Here's the one that is trickier. 5th root of 3 over 4. Okay, this can be written as 5th root of 3 over 5th root of 4, right? And we talked this before. This is the trickiest one of the whole chapter, where we cannot have a square root on the bottom of a fraction. My mind went blank, okay? I can write this 4 as 2 to the 2nd power. I know that part. I need 5 of them, right? I need 5 of these in order to pull them out, which means I'm going to have to time by the same root, and I need a 2 to the 3rd. Why? Because when I times the same base, I can just add an exponent, right? So I need 3 more. If I do that here, I must do it here. I have to do it in both places, right? What do I get? Root 5 of 3 times root 5. 2 to the 3rd is 8. So on the top, I can put it as an 8. The bottom becomes root 5 of 2 to the 5th power, correct? 2 plus 3 is 5. That's all I need. This cancels that out. This becomes root 5 of 24 all over 2. You cannot reduce anymore, and here's why. 24, 2, 12, 2, 6, 2, 3. I need 5 of a kind to pull stuff out. I only have 3 2s. That just doesn't reduce, okay? So, I guess the trickiest part of this would be to solve stuff like that. What if we have 4th root of 3 over, I don't even know. I'm going to use 5 just for the sake of it. Well, this becomes root 4 of 3 over root 4 of 5. 5 is not a perfect square of anything. This is not in the book. I'm doing one extra example for you. I have a 5 to the 1st. I need 4 of them. I'm going to have to times that with the same root, 5 to the 3rd. When I add them up, I get a 4th. If I do this, I'm going to do it here. Okay? What do I get? Root 4 of 3 times, it can be put on the same thing. 5 to the 3rd is 125. This becomes root 4 of 5 to the 4th. Why? I already know I'm going to get. That's why I timed it with. 1 plus 3 gives me that 4. This cancels this. This becomes root 4 of 375 over 5. That does not reduce anymore. I already know what that is. That is 3 times 5 times 5 times 5. I need 4 of a kind. I only have 3 of a kind, and we're done. I did one extra because I wanted to make sure you know how we do this in order to get rid of the square root of any type of root on the bottom. As we move on to example 4, we have all kind of operations that we play with this. And I anticipate you having the most trouble with this lesson. We're going to make it through it. What if I have 7 times 6 to 1/5 plus 2 times 6 to 1/5? Well, remember how they have this in common? Well, time plus 2 times 6. Well, this becomes 6 to 1/5. I can factor it out. 7 times 2, which is 6 to 1/5 times 14. Right? Times 9. And we leave it there. I do not know why I thought it was 14. Oh, because this is a plus. I factor that out. It's 7 plus 2 gives me 9. And that's where we leave it. We don't do anything else with it. That's the only thing that you need to know. What if I have root 3 of 16 minus root 3 of 2? Well, right now, they're definitely not apples and oranges. They don't look good to each other, right? There's 2 ways to solve this. The easiest way is to look at this and look at 16 and go 2, 8, 2, 4, 2, 2. All primes. I need 3 of a kind to pull one out. I do have 3. I can pull this one out and go 2, root 3 of 1, 2 left there, minus root 3 of 2. And if you need to have a number in front of it, you can put a 1 here. So I have 2 apples minus 1 apple gives me 1 squared of, cube root of 3, right? So what I could do was simplify this to where they became apples and apples, and all I have to do now is worry about the coefficients. 2 minus 1 gives me 1 apple, or 1 cube root of 3. That's how we simplify stuff like that. Now, if you think this was it, it wasn't it. But we're not far from being done. We have a little bit of stuff, but not much. What if they say simplify the expression? Cube root of 125 y to the 6. Literally the fastest way to, well, the clear way to do this is to go 125, 525, 5, 5. They're all prime, so this becomes 5 times 5 times 5 times y times y times y times y times y times y. I need 3 of a kind to pull one out. I have 3 5s, I can pull one out. There's 3 y's, 1 comes out. Oh wait, I have another 3y, 1 comes out, and there's no more squares, nothing under the square root, so this just becomes 5y to the second. The other way to look at this would be to do it. This becomes 125 to 1 over 3 times y to 6 over 3, right? Remember how we said when we write them as rational exponents becomes 1 over whatever the root is, and then 6 over whatever the root is. Well, 125 to 130, if you put it in your calculator, gives you 5. 6 divided by 3 is 2, and you got it that way. So either way you want to do it will work just as much, okay? Let's look at another example. It tells us 9u to the second, v to the 10th, and all of it to 1/2. Well, remember we can distribute this as 9 to 1/2 times u to the second all to 1/2 times v to the 10th all to 1/2. This one, put in your calculator. That's going to give you 3, because that's square root of 9, which is 3. 2 times 1/2, this becomes u to the first power. I don't have to put it in. Times v, 10 times 1/2, v to the 5th power. Okay, we just apply the distribution property that we have and then work it out from there. What if we have 4th root of x to the 4th all over y to the 8th? Well, this becomes 4 root of x to the 4th over 4 root of y to the 8th. We're going to write this in as rational exponents. Why? We like that division better. This becomes x to the 4 over 4. This goes on the top. That goes on the bottom. over y to the 8th over 4. This goes on the top. The little thing in the v goes on the bottom. X over y to the second. 4 divided by 4, 1. I don't have to write it down. 8 divided by 4, 2. And there's my answer. Let's do the last example before we move on to greener pastures that you're going to hate. 6xy to 1 over 2 all over 2 x to 1/2. I think so. 1/3. Z to the negative 5. Make sure I got this right. I did. So let's go ahead and write this the right way. 6 divided by 2. 3. I have an x and an x. This becomes x to 1 minus 1 over 3, right? Y to 1/2. In order for this z to become positive, I have to move it on the top. So it's z to the 5, right? We moved it to the top. We made it positive. Let's do this. 3 x to 2 over 3, y to 1/2, z to the 5th. The great news is you're done. We don't have to do anything else, but all of my exponents are positive. All of the operations are done. This is the end of the road for us. How do we bring variable expression to simple forms? 5th root of 5, a to the 5th, b to the 9th, c to the 13th. I'm going to teach you a trick in here, okay? I know I'm going to end up with a 5th root. We did this in class too. 5th root of 5, you cannot pull out. It's going to stay in there. I have 5 a's. I need 5. 1 come out. How many b's do I have? I have 9. How many do I need to come out? I need 5. So b come out. What am I left with if I pulled 5 out? 4, right? 4 are not enough. B to the 4th. Correct? How many c's do I have? I have 13. How many do I need to pull 1 out? I need 5. I can't pull 1 out. I'm left with 8. Can I pull 1 more out? Yes, I can. I'm left with 3. C to the 3rd. So if you look at this, I need 5 to pull 1 out. I'm left with C to the 8th. And I go, wait, I still have enough. I can still pull 5. And I'm left to C to the 3rd. I have 2 C's out. 3 C's stay inside. So every time you have to work on these, you think of this and you go, I need to have this many. How many do I have? How many can I pull out? How many are staying in? Now, the other way to do it would have been to write this as 5th. I have a to the 5th, b to the 5th, c to the 10th times 5th of. I pull all my a's out. I'm still left with 4 b's, and I'm left with only 3 c's. This becomes a, b, c to the 2nd, 5th root 5, b to the 4th, c to the 3rd. I think the way I did it first is going to be more easy for you to work on. The last one we're going to deal with, it's not a nice one, but it's okay. Cube root of x over y to the 7th. This is going to be cube root of x. We're going to separate first things. Cube root of y to the 7th. I cannot do anything to the top yet. Cube root of x. But on the bottom, I need 3. I have 7. I can pull 1y. I'm left with 4. I can put another y. I'm now left with 1. So this is 3y. A cube root of just y. Okay? I can't leave it here though, if you think about it on. So I would now have to think I have 1. I need 2 more. I'm going to times this by cube root of y to the 2nd. Cube root of y to the 2nd. On the top, they can be combined, x, y to the 2nd. They're the same kind of root. They can be combined. The bottom now becomes y to the 2nd times. I have 3 of them. 1, y to the 1st, or I can just write this as y to the 3rd, and I am done. Okay. The way the book did it, and I want you to look at that also, is they separated the two things and then they went. I have 7. If I times it by another cube root to the second, I get to 9. 9 divides 3 evenly. I want to get there. Times cube root of y to the second. This becomes cube root of x y to the second all over cube root of y to the ninth. We add them, right? So now we're going final step, 3xy to the second all over. I need 3. I can pull one out. I have y to the 6th. I need another 3. I can put another one out. I have 3. I can put now another out, and everything is gone. We are good to go, right? The other way to look at it is 9 divided by 3 gives me 3. If we do rational exponents, either way it will work. No matter how you approach it, it will work the exact same way. We have other operations, and this is going to be a long video. This is a long subchapter. 5 square root of y. I'm not going to work this. We're on page 409. You can look at this. If I have 5 square root of y plus 6 square root of y, I have 5 apples plus 6 apples. I get 11 apples. Pretty easy. If I do 2xy to the 1/3 minus 7xy to 1/3, again, I have 2 apples minus 7 apples. I get negative 5x to 1/3. The only one I want to work is the third one. Is 3 cube root of 5x to the 5th minus x cube root of 40 x to the second. We're looking at this and going, can I solve this or can I not solve this? Well, let's look at this. I have 5. I need 3 to come out. This becomes 5x to the second, right? That's what I have left. I pull 3 out to pull 1 out. I'm left with 2. Minus, what about 40? How can I write 40? 40 is 8 times 5. 5 is prime. 4 and 2. 2 and 2. How many do I need to pull 1 out? I need 3. I have 3 2's. This becomes 2x cube root of what's left? 5x to the second. We're back to apples and oranges. Apples and apples, not apple. I don't know why I said that. 3x minus 3 apples minus 2 apples. This becomes 1x cube root of 5x to the second, right? We always look to simplify and reduce stuff to get to where we need to be. The last thing we're going to look at is the word problems. This is a long video, guys. It says evaluating a model using properties of rational exponent. They give you a table over there, and they tell you you have this model. S equals K times M to the 2/3. And that stands for M is mass in grams, and S is the surface of a mammal, right? They give you all kind of stuff there, and it says approximate S of a cat that has the mass of 5 kilograms. You need the mass in grams. So 5 kilograms equals 5,000 grams. Okay. They did it a little bit different over there. I'm not going to bother with it. We're going to get the same result. This becomes K, which is a cat. Your K is 10 times 5,000 to 2/3. And if you just plug this into your calculator, you don't have to do anything to it. If you just go and say 10 times 5,000 raised to parentheses 2 divided by 3, you get the exact same answer they did. 2920. They wanted to approximate it. They clearly approximated it. It's 2924 in my math. 2924 whatever, square centimeters. And if they actually approximately up, so they made it about 3,000 square centimeters, okay? But that's, if you give me that answer, I'm pretty happy with it, okay? The last thing is example 9. The only trick with this word problem was to convert from kilograms to grams. That's the part that you need to know. The last one, you have the same thing, they say you're studying a Canadian lynx whose mass is twice the mass of an average house cat. So really what you're looking at is the S of a lynx is 10 times 2m to the 2 over 3, because it's twice the mass. The same thing is staying there. It says what it is a surface area also twice as an average house cat. So they want to know what is this over the surface of a cat, which is 10m to 2 over 3, right? That's what we know about this. So if I do this division, 10 divided by 10 gives me 1. Then I have 2m over m all to the 2 over 3. Correct? If I write this together, I go numbers with numbers, and they have the exact same exponents. I can actually put them all together, right? So this becomes 1 times 2 to the 2 over 3. That reduces. And if I do that in the calculator and I go, basically all I need to do is what is 2 raised to the parenthesis 2 divided by 3. I end up with 1.59. It's about 1.59 when I put this in the calculator. And it says it's about 1.5 times of the average cat. So no, it's not twice as much. It's less than that. Okay. This was a long video with a lot of information, and I anticipate you hating your homework. But it's okay. We'll make it through. Happy homework.